The camshaft, one of the hardest working components in any piston engine, and a frequent source of premature wear and failure. G'day, I'm Matt from KCK Lubricants, and today let's talk about camshaft wear. I'd like to start today's video with a question. Which camshaft lobe do you think sees more load? The intake lobe or the exhaust lobe? Leave a comment below and let us know what you think. Which camshaft lobe would you expect to see more wear on? The intake or the exhaust lobe? We'll come back to that a little bit later and I'll give you the answer. Now, when we talk about camshaft wear, we need to divide the camshaft lobe up into three parts. The opening ramp, the nose of the lobe, and the closing ramp. This will help us better understand what's going on within the valve train that may be causing these issues. If we look at the opening ramp, for example, if we have excessive valve lash or a failed hydraulic lifter, we would expect to see a large amount of hammering on the opening lobe. Now, this is basically where the lifter is now hitting that lobe so hard, it's breaking the oil film and we're getting steel on steel contact, and it damages the facing of the camshaft very fast and causes these premature wear issues. Failed hydraulic lifters are quite common for this sort of problem, and the leading cause of our lifter failure is debris in the oiling system. And a lot of this is when the engine's first assembled. The lifters aren't cleaned properly or the block itself isn't cleaned properly. After a failure, when there's a large amount of shrapnel throughout the oiling system, really important to make sure everything's incredibly clean. Once the engine's operating, the lifters only receive filtered oil, so it's a lot less unlikely that you'll have a lifter failure further down the track. But a lot of the LS engines, for example, we see lifter failures almost immediately because the blocks haven't been cleaned enough. So that's one of the leading causes for camshaft lobe wear on the opening side. Now, on the nose of the cam, this is more either mechanical bind or your oil selection isn't correct and your oil isn't up to the task. So as we get more aggressive on the opening ramps and the closing ramps, and as we get more lift, we need a heavier valve spring to control the valve. The job of the valve spring is to keep the weight of all the valve train under check and to keep that roller or the lifter in contact with the lobe at all times. And by going to a much heavier valve spring, more coils, thicker coils, we're more susceptible to coil bind. So if we come up to full lift and we get coil bind, there's very little flex in that entire system, and it will just put excessive load on the nose of the cam and cause damage to the facing. It will break down the oil film, damage will occur, and you'll wear the nose off the lobe. Another thing to consider is for the roller rockers. There's a slot in the bottom of that rocker, and it needs a fair bit of clearance. If it's hasn't been checked and it's coming hard up on the pedestal, once again, that's a mechanical load that nothing will overcome, and it will just chew the nose off the camshaft. And it's really critical, guys, to spend the time and double check everything. We've seen a lot of engines that have been put together with all the best parts and still fail because nothing's been checked. And whether it's coil bind, the back of the retainers hitting the top of the valve stem, or rocker interference, whether that be the retainer hitting the rocker or the rocker bottoming it out on the pivot bolt. Really important to check to make sure it's not only not binding, but you've got the necessary clearance within the coils and for the rocker. So that eliminates the nose. So whether it be mechanical binding or your oil just isn't up to the task, if you're using a standard oil or a low zinc oil, it will not meet the necessary requirements for a performance camshaft because it is working that much harder. On the closing ramp of the camshaft lobe, if we have slight divots in the closing ramp, this may be because the valve spring isn't heavy enough. The lifter's coming over the nose of the lobe and throwing the valve, you're essentially getting valve float, and then it's coming back on the closing ramp and hammering into the closing ramp. Once again, breaking down the oil film, you get the metal on metal contact, and damage to the facing on the closing ramp will quickly occur, causing all sorts of issues, as you could imagine. So valve spring and valve float will cause damage on the closing ramp of the exhaust of the camshaft lobe. Another thing, when we talk about wear, total lobe wear or total lobe failure often comes back to lifter issues, whether that be a roller lifter or a flat tappet lifter. If that roller or the flat tappet doesn't begin to spin immediately on startup when that engine is first started, it will always favour that point at which it skid, and it will continue to skid and it will fail. So really important that the startup procedure is critical, especially for flat tappets. But even for the hydraulic rollers or the solid rollers, if that roller begins to skid, it's over. It may take 500 miles for the camshaft to fail, but it will still fail. It's inevitable. And once again, that's an assembly problem, whether the lifters haven't been properly cleaned and there's debris in them, or they haven't been pre-lubricated. Now keep in mind, when you put together a brand new engine, if the oiling system isn't primed, it takes a long time for the oil to get to the lifter, to fill the lifter, and to travel up the push rod. So the push rod is dry in either socket if you haven't used assembly lube, and this will gall and fail really quick. If you have big valve springs, high lift cam, that's under an immense amount of load. And once again, you have steel on steel contact in the ball of the roller rocker, the end of the lifters, and the push rod itself. Another problem we see, sorry burnout guys, but limiter bashing. Limiter bashing gives you uneven and unpredictable cylinder pressures and will cause hammering on the full camshaft lobe itself, and a lot of hammering on the lifters. So if you pull it apart and you might have a smashed roller on your lifter, probably from limiter bashing. We see a lot of cracked lifters will even break the sides off the lobes. Nothing to do with how the camshaft was manufactured, nothing to do with the oil itself, just inappropriate use. It's ignition cut rev limiters, they sound awesome, but cause all sorts of issues within the engine with uneven cylinder pressures, whether that's the valve getting hammered back mid-stroke or whatever, but it really puts the lobe pressures through the roof. Now, while we're talking about cylinder pressures, we'll get back to the original question. Which lobe would you expect to see more wear on, the intake or the exhaust lobe? Well, the intake's got the bigger valve, more valve train weight, but the exhaust needs to open the valve against cylinder pressure. So you'll almost always see more wear on the exhaust lobe of the camshaft because of the cylinder pressure. I hope that explains some of the fundamentals and some of the basics on what causes camshaft lobe wear. But just remember, you need a specific oil for your application. You can't run a standard oil in a performance engine. It's so far outside of what that oil's designed to do. You need a performance engine oil for a performance engine. It's as simple as that. And it's critical for camshaft wear in particular, where it is steel on steel contact. The lobes aren't pressure fed. Really critical to have a proper performance engine oil to perfect that camshaft. Thanks guys, thanks for watching. Subscribe if you haven't subscribed. Leave a comment, share it with your buddies. Give it a thumbs up if you liked it. See you next time.